Hello, I'm Sri from CBTU. CBTU presents a course on cloud computing. Section Introduction. This is overview of cloud computing. Cloud computing is nothing but on-demand network access to a shared pool of configurable computer resources, like applications, platforms, and infrastructure. Example includes networks, servers, storage, applications, and services. Cloud computing enables access over the internet to shared pool of computer resources. The cloud resources can be accessed by any of the cloud clients like laptops, mobile phones, tablets, desktops, and servers. The benefit of cloud computing is they can be provisioned very quickly and is similar to public utility, always available, reliable, and pay only for what you use. The main enabler behind cloud computing is virtualization. Virtualization software separates physical computing device into one or more virtual devices, each of which can be easily used and managed to perform computing tasks. We have mainly three service models for cloud computing. At infrastructure level, we have infrastructure as service. This includes virtual machines, servers, storage, load balancers, network, etc. The next layer is at platform. It is platform as service, PaaS. This includes execution runtime, database, web server, development tools, etc. And the next level of cloud computing is at application level. It is software as service, SaaS. This includes CRM applications like Salesforce, email, virtual desktop, communication, and gaming, multiple users playing online games. All these services are accessed by cloud clients like web browser, mobile app, thin client, terminal emulators, and others. This is a base classification. And now we are coming out with service oriented architectures that says everything is a service. XaaS, XaaS. We're going to see the comparison of various service models in the coming sessions. We got trusted, proven cloud service providers. They include Microsoft Azure, Amazon Web Services, Google Cloud Platform, IBM Cloud, Rackspace, Verizon Cloud, and many others. Cloud computing compares with other models like client server model, grid computing, fog computing, mainframe computer, utility computing, peer-to-peer computing, green computing, cloud sandbox, and others. Basically, cloud computing is a client server distribution model. Clients access applications and services that are available in the cloud and accessed over the internet. Client-server model refers to any distributed applications that distinguishes between service providers and service requesters, which are clients. Cloud computing has various benefits, and the main benefits and the characteristics are cost reductions come with just operational expenditure OPEX only with little or nil capital expenditure CAPEX. And the services can be accessed from anywhere without dependence on the location or the devices. Access from anywhere. It enables users to access resources connecting through a web browser over the internet. Cloud is agile platform and easy to maintain. Multi-tenancy is the main feature of cloud computing. This enables sharing of resources and costs across a large pool of users. This multi-tenancy allows centralization of resources and manage peak load capacity and better utilization and efficiency. Performance of the resources is monitored and consistent in the cloud architectures. Productivity is highly increased as multiple users can work on the same data simultaneously. Cloud computing is highly reliable with the use of multiple redundant sites. This is suitable for business continuity and disaster recovery. BC and DR. Another fantastic feature of cloud computing is scalability and elasticity. The resources can be provisioned on demand in real time. This gives the ability to scale up or scale down as per the dynamic needs of the organization. Another factor of cloud is it's always questioned for its security. As the data resides in the cloud with multi-tenant systems shared by multiple users. These service providers have come up with all kinds of security certifications and providing the full control over the infrastructure and offering the near on-premises security in the cloud. Various security methods, features are implemented by the service providers to secure clients' data and provide on-premises equivalent security. One prefers cloud to the on-premises because of these features, enabling strong access methods, encryption methods, implementing security recommendations can make cloud more secure. The National Institute of Standards and Technology (NIST's) definition of cloud computing identifies five essential characteristics. They are on-demand self-service. This is automatic provisioning capabilities. Broad network access. Capability to access from thin or thick client platforms like mobile phones, tablets, laptops, and workstations. Resource pooling. The resources are pooled and multi-tenant model is used to meet the consumer demand. Rapid elasticity. Elastically scaling up or scaling down the resources as per need. Measured device. This is to optimize the resource usage. Cloud Computing Service Models Infrastructure as Service (IaaS). IaaS offers physical or virtual machines and other resources in the cloud. A hypervisor such as VMware ESXi or Hyper-V runs the virtual machines as guests. Pool of hypervisors within the cloud operational system can support large number of virtual machines and the ability to scale services up and down according to customers' dynamic varying requirements. Cloud users install operating system images and their application software in the cloud infrastructure. IaaS offers physical or virtual machines and other resources. A hypervisor runs the virtual machines as guests. In this model, the cloud user patches and maintains the operating system and the application software. Cloud service providers typically bill IaaS services on a utility computing basis, like pay as you go, pay only for what you use. Platform as a service (PaaS). In this, customers do not manage or control the underlying cloud infrastructure, including network, servers, operating systems, or storage, but have control over the deployed applications and possibly configuration settings for the application hosting environment. Some examples of PaaS are Oracle Cloud Platform and IBM Bluemix. Software as a service. The examples are Salesforce application, email applications like Gmail. In this, we are not worrying about the infrastructure or the platform, just using the software as an end user. We access the applications in all the service models, web browser, mobile app, thin client, and emulator. The deployment models, the cloud computing types. We have the public cloud, that is external, private, that is internal, and public private, mixture of these two combination. Public service providers like Amazon AWS, Microsoft Azure, Google Cloud Platform, these own and operate the infrastructure at their data center and offer products and services like computing, applications hosting, web hosting, storage, and other resources accessible over the internet. Private cloud is cloud infrastructure private to an organization. Private cloud is local and can be accessed over the intranet, whereas public cloud is accessed over the internet. Public cloud weighs over the private cloud in terms of low capex and just OpEx and security concerns. Hybrid cloud is a combination of private, community cloud, and public clouds, offering the benefits of multi deployment models. In hybrid cloud, an organization may store sensitive client data in-house on a private cloud application and interconnect that application to a business intelligence application provided on a public cloud as a software as a service. This example of hybrid cloud extends the capabilities of an enterprise to deliver a specific business service. And hybrid cloud can also be suitable to meet temporary capacity needs that can't be met by own private cloud. This capability enables hybrid clouds to employ cloud bursting for scaling across the clouds with pay for what is used only. Gartner defines a hybrid cloud server as a cloud computing service that is composed of some combination of private, public, and community cloud services. It allows one to extend either the capacity or the capability of a cloud service by aggregation, integration, or customization with another cloud service. Here there are two terms, cloud architecture and cloud engineering. Cloud architecture is the software systems involved in the delivery of cloud computing using multiple cloud components, whereas cloud engineering is the application of engineering disciplines to cloud computing. There is a big concern of security and privacy in the cloud. Some of the concerns are the service provider can access the data that is in the cloud, accidentally or deliberately alter or even delete information, share the information with third parties for the purposes of law enforcement, even without a notice or a warrant. And some of the countermeasures are the legal aspect, we cannot do anything but check the agreements on permissions and policies and encrypt the data to safeguard your organizational data. Thanks for watching.